Below is a much longer version of the passage, approximately twice the original length. It retains the core ideas, but provides additional details, explanations, and context to expand upon each point. We often take our planet's seamless functionality for granted, rarely pausing to consider its inherent fragility. At first glance, Earth appears robust. It has a balanced climate system, abundant water, diverse ecosystems, and a layered atmosphere that protects us from space radiation. Yet this seeming perfection hides a delicate equilibrium. If we were to alter even a single critical factor, the entire system could come crashing down, making our world suddenly hostile to life as we know it. Among the most dramatic scenarios that demonstrate Earth's vulnerability is the notion of it simply stopping its spin. Though this might sound impossible, understanding its implications reveals just how tenuous our planetary home truly is. 1. Two types of planetary motion. 1.1. Orbiting the Sun. Every year, roughly 365.25 days, our planet completes an orbit around the Sun. This journey takes us across vast stretches of space, maintaining an average distance of about 150 million kilometers from our star. The speed required to keep us from falling inward is immense. One can imagine this as being on a hyperspeed merry-go-round. So long as we're whipping around quickly enough, we don't tumble toward the gravitational center. If Earth were to lose that orbital velocity, we'd spiral into the Sun in a matter of time, leading to a cataclysmic fate where Earth itself would be torn apart by searing solar plasma. 1.2. Spinning on its axis. In addition to orbiting the Sun, Earth spins around its own axis. This rotation takes approximately 23 hours, 56 minutes, and 4 seconds, close enough that we round it to 24 hours for our daily routine. The spinning gives us day and night, drives weather patterns, influences ocean currents, and generally sustains life-friendly conditions across the globe. It also flattens Earth slightly at the poles and bulges out at the equator, which affects sea levels, atmospheric circulation, and more. The interplay of these two motions, orbital revolution and axial rotation, ensures that we experience consistent seasons, stable day-night cycles, and a climate conducive to biodiversity. 2. Stopping Earth's orbit around the Sun, the ultimate doom. Suppose, hypothetically, that Earth halted its entire orbit. This scenario is both extreme and almost incomprehensible, yet contemplating it clarifies how essential our planet's orbital speed is. 1. Instant standstill and rapid collapse. If Earth's orbital motion ceased in the blink of an eye, everything not bolted down would continue flying through space at about 107,000 kilometers per hour, which is Earth's usual orbital speed around the Sun. The planet itself would disintegrate under colossal stresses, scattering debris across the solar system. Fragments of Earth's crust, mantle, and core, along with all life forms, would careen into interplanetary space. Some of that wreckage might orbit the Sun as a newly formed asteroid field. 2. Gradual slowdown and death spiral. A more drawn-out deceleration might spare Earth from immediate disintegration, but we'd be doomed to spiral toward the Sun. In that scenario, we would gradually lose our comfortable distance from the star, causing surface temperatures to climb. Oceans would boil away, turning the planet into a colossal steam bath until everything perished. Eventually, crossing a certain threshold of solar proximity, likely tens of millions of kilometers closer than we are now, Earth would superheat to the point where no life could persist. Our final resting place would be the Sun's blazing outer layers, dissolving Earth into elemental gases within seconds. 3. Halting Earth's daily spin, a less obvious catastrophe. Yet there's another kind of stop we can contemplate. Earth preserving its solar orbit, but no longer rotating on its axis. At first glance, one might think losing our day-night cycle sounds more manageable than plunging into the sun. But in reality, the abrupt end of axial rotation is devastating for humanity and all complex life in many ways. 3.1. Instantaneous stop of the spin. Massive overload. Earth's equatorial surface speed is about 1,670 kilometers per hour, over 1,000 mph. If that velocity vanished in seconds, any object or being at lower latitudes would be flung westward, experiencing roughly 47 G of force. This is lethal to humans and damaging to nearly every structure. Relentless tsunamis and earthquakes. The oceans, which hold 1.338 billion cubic kilometers of water, would also continue surging forward. Towering walls of water would crash onto coastlines, traveling at astonishing speeds. Seismic shocks, triggered by the abrupt deceleration, would fracture the planet's crust. Survival prospects. Only people near the poles might endure the initial shocks, since the rotational velocity there is near zero. But even for them, the subsequent shock waves, floods, and global chaos would drastically reduce their odds of pulling through. R3.2. Slower, gradual halt in spin. Slightly less disastrous, but still dire. If Earth's spin decreased over weeks, months, or years, we wouldn't suffer a 47 G jolt. However, new challenges would emerge. Massive storms would move water from the bulging equator toward the poles, forming new superoceans, while previously submerged areas would become continental highlands. Magnetic field consequences. Earth's rotating molten iron core generates our magnetic field, which shields us from solar and cosmic radiation. A deceleration of daily rotation likely weakens that protective barrier, eventually turning Earth into a radiation-soaked environment. Those who avoid floods and famine might still perish from higher levels of cosmic rays. Mission 4. Life on a non-rotating world. Imagine Earth slowed so much that one day equaled 1 year, making the planet tidally locked to the sun, similar to how the moon shows only one face to Earth. One side would perpetually bake in sunlight, while the other would remain in freezing darkness. The twilight zone between these two extremes might allow life of some sort, but it's hardly guaranteed to be a paradise. 1. Flora and fauna in peril. On the eternal daylight side, many plants might be scorched unless they adapt to blistering heat and intense light. On the eternal night side, photosynthesis becomes impossible for traditional vegetation. Only shade-tolerant or cold-resistant species, possibly fungi or mosses, might survive. Animals reliant on stable daylight cycles, varied climates, and an abundance of vegetation would vanish, especially large mammals and birds that demand well-developed ecosystems. 2. Oceanic shifts and desertification. The side facing the sun could turn into a scorching desert, while the dark side becomes an icy wasteland. Enormous thermal winds would blast between these hemispheres. Intense atmospheric circulation could form storms dwarfing any hurricane we've recorded. Over time, the geophysical shape of the planet might change as water tries to migrate to cooler regions, further complicating climate patterns. 3. Human adaptation. Humanity would likely be forced to cluster in narrow zones that maintain reasonable temperatures. Even so, farmland would be drastically reduced, leading to global famine unless advanced hydroponics or underground horticulture were developed. A diminished magnetic field would exacerbate the radiation problem, compelling many to shelter in subterranean environments. This scenario could persist for millennia, altering humans' way of life beyond recognition. Rashi 5. Why Earth's spin is actually slowing already. In a far less dramatic manner, Earth is indeed slowing down. Every century, our day lengthens by about 1.5 to 2 milliseconds, mostly due to tidal forces. The moon's gravitational pull creates bulges of water, tides in our oceans. Friction from these bulges steals angular momentum from Earth, gradually reducing the planet's spin. Over vast timescales, this could culminate in an Earth day growing from 24 hours to, say, 25 hours, and eventually, in billions of years, achieving tidal lock with the Sun, assuming other cosmic events don't intervene first. 1. Gravitational interactions. The Moon influences our tides more than the Sun in terms of generating tidal bulges. Water molecules along Earth's surface are drawn toward the Moon, causing cyclical rises and falls. The energy dissipated by these moving tides effectively works like a braking mechanism, slowing Earth's rotation. Simultaneously, the Moon drifts about 3.8 centimeters away from Earth each year. 2. Long-term future. In 5 to 6 billion years, the Sun may expand into a red giant before Earth ever becomes tidally locked. If Earth were swallowed by the Sun, that alone would determine our planet's fate. If our planet somehow escapes the red giant phase, it might eventually match its rotation to its orbital period, ensuring one hemisphere faces the Sun forever. Life, if it exists then, would look nothing like our current ecosystems. 6. The broader cosmic perspective. Interestingly, astronomers have discovered exoplanets that likely experience this endless day and endless night scenario. One example is the TRAPPIST-1 system, located about 39.5 light-years away, where several Earth-sized planets orbit a red dwarf star very closely. Because these planets complete orbits in a matter of days, it's almost certain some are tidally locked. If any harbor life, it would need to adapt to conditions far more extreme than what we experience. For humans, learning about such exoplanets might provide hints on whether life can truly exist in a world with no daily rotation. Perhaps advanced technology could allow distant future travelers to visit these tidally locked worlds, witnessing conditions unimaginable to us. It's a testament to the resilience and adaptability of life. But we don't actually know if those worlds harbor life at all. Catastrophic 7. Why worry about theoretical stops? You might wonder why we focus on hypothetical scenarios, such as Earth ceasing its axial or orbital rotation. While these possibilities are minuscule under normal physics, studying them reminds us how thin the margin for stability can be. We live in a universe subject to events like asteroid impacts, gravitational interactions with rogue objects, and expansions of stars into red giants. Even if an abrupt halt to Earth's spin is virtually impossible by natural means, it provides an extreme scenario that underscores the complexity of our planet's delicate balances. 1. Encouraging curiosity and preparedness. Examining outlandish what-if cases fosters deeper appreciation for Earth's normal processes. We become more aware of how interconnected climate, rotation, tides, and core dynamics are. Recognizing potential catastrophes, even if improbable, drives technological advancement like early warning systems for other disasters, and fosters a mindset of stewardship over our fragile biosphere. 2. Understanding tidal lock in our solar system. The Moon has been tidally locked to Earth for millions of years, showing us the same face, perpetually. By studying why, we learn about angular momentum and how bodies synchronize over time. Mercury is tidally locked in a 3-2 resonance with the Sun, not showing the exact same face continuously, but maintaining a stable ratio between its orbital and rotational periods. These glimpses inform us about long-term celestial dynamics. 28. The ultimate takeaway, embracing Earth's fragile gifts. From the spinning, magnetized core that shelters us from radiation to the precisely balanced orbit that prevents us from plunging into the Sun, Earth is a finely tuned masterpiece of cosmic engineering. A small change, like halting its spin, would unravel countless layers of stability in ways we can scarcely survive. Though it's reassuring to note that an immediate stop isn't on any realistic horizon, the point is clear. Our planet's everyday stability is more precious and delicate than we tend to acknowledge. 1. Profound connections. The day-night cycle influences plants, animals, weather, and human culture. We measure time by it, structure societies around it, and rely on its consistency to grow crops and plan daily life. Earth's rotation indirectly shapes ocean currents and wind patterns that distribute heat across the globe, enabling diverse climates where life flourishes. 2. Reflecting on cosmic scales. Over billions of years, entire star systems can morph, stars can die, and planets can be reshaped or destroyed. Earth's rotational changes are only a tiny part of broader cosmic processes. Whether or not a slowdown or tidal lock drastically changes Earth within a few billion years, knowledge of this potential fosters a deeper humility about our place in the cosmos. 3. Remaining vigilant and curious. Understanding improbable scenarios spurs scientific curiosity. By continuously refining our models and verifying them with observations, from plate tectonics to tidal interactions, we gain insights into Earth's future. We also cultivate better awareness of external threats, like rogue asteroids, or internal processes, like core cooling, that could influence habitability. 9. Looking ahead, our role in protecting a spinning world. While it's comforting to know that cosmic events required to stop Earth's spin are far outside the bounds of normal astrophysics, we do face more imminent issues like climate change, resource depletion, and potential asteroid impacts. We also rely heavily on a stable environment for agriculture, infrastructure, and daily life. A thoughtful approach to Earth's fragility, recognizing that even unlikely scenarios confirm the razor-thin line we walk, can motivate us to cherish and safeguard this planet. 1. Stewardship of life. Earth's systems, its rotation, magnetic shield, and orbit, support a tapestry of life that has evolved over billions of years. Each day of normal sunrise and sunset is a gift. We must strive to preserve the biodiversity that thrives under these conditions. While no human action can instantly halt Earth's spin, we do influence the climate and environment in other ways, revealing our capacity to destabilize the planet. 2. Inspiration for exploration. The hypothetical stopping of Earth's spin also nudges us to look outward. If life can adapt here under extreme changes, perhaps it can adapt or exist on other extreme exoplanets. Missions to study tidally locked planets could, in the future, reveal whether life finds a foothold in places with endless daytime or perpetual night. 10. Conclusion: a world on the move. In sum, Earth's spin is fundamental to our existence. Losing the daily rotation overnight would subject us to catastrophic forces, insurmountable for modern civilization. A slower deceleration over millions of years would still produce a world unrecognizable to us. split between permanent day and permanent night, battered by extreme weather, lacking a strong protective magnetosphere, and struggling to sustain abundant life. Our current reality, however, is that Earth spins reliably once every 23 hours, 56 minutes, and 4 seconds, day in and day out. That cycle underlies life's rhythms and ensures we remain in the comfortable, stable environment we call home. By appreciating these otherwise invisible cosmic gears, we cultivate a renewed sense of wonder for our planet's delicate balances and the determination to ensure they continue for as long as possible. We invite you to contemplate these ideas and share your reflections. If you're fascinated by the hypothetical, the scientific, or the sheer awe of our planet's daily cycles, let us know in the comments, and don't forget to subscribe. There's always more to discover about our astounding universe.